Okay. So we're just going to take a look at the equation of a circle today, which likelihood of you guys seeing might be pretty small, but it's kind of interesting where it comes from. So a circle is a set of points in a plane that are the same, what do you think? They're all the same distance from a fixed that's not right. Okay. I don't know. Today's going to be one of these days. Is it ER or RE?
It can be spelled both ways, but they mean different sentences.
Okay, that's too advanced for me right now. Two different ways to spell each letter. I can't do it right now. Okay. So the interesting thing with this is, I'm going to try and pick a nice point here, but the likelihood of that working is not good. So let's just pick right here, for instance. Okay. Now, it always comes back to triangles. I'm going to connect these two lines, or the 2 points, to create a line segment, okay? Right? And then, like all of other, like the line segments, like what we saw yesterday with the midpoint, we always had like kind of an X piece and a Y piece, right? So I can almost basically create a triangle. Right, this thing's going to have a Y piece, and it's also going to have an X piece. Okay. I now have a triangle on my page, right? The black piece to get out to the outer edge is what we're going to call R, or your radius, which you should have already seen before, okay? What we want to develop is an equation that allows us to write what R is equal to, basically, right? So from, like, I see a triangle on my page, so anytime I see specifically a right angle one, right? So anytime I see a right angle triangle, you can always kind of use Pythagorean theorem, right? Okay, and we always said that C was always the hypotenuse, right? So in our question here, the hypotenuse is R squared. And then A and B are just the other two pieces. X squared plus Y squared. Okay. Well, it turns out this is the equation of a circle when it's centered at the origin, right here. The origin being 0, 0. Okay, so down here in the box, you can go x squared plus y squared equals r squared. That's where the equation of a circle comes from. Okay. I think that's kind of cool in the sense that, like, we've taken, I don't know, we're just connecting concepts, right? But what you guys are going to see next year is there's this thing called the unit circle, which can give a lot of kids trouble in terms of its understanding of where it comes from. But if you understand this, equation, all of a sudden the unit circle just, like, it makes so much sense. Didn't know that until I actually taught the 3U course. I was like, oh, it just blew my mind. Okay. Doesn't mean anything to you right now, but there's a bigger picture with that equation, right? And it'll help you in trig when you get there. Okay? Any questions so far? It's kind of cool that, I don't know, you turn a triangle into a circle somehow. It's just how the two are related, I think, is kind of cool. Right? So it doesn't matter. It doesn't matter which point I pick on the circle, right? I could pick it over here, it's always going to have a y piece and it's always going to have an x piece, but it's a radius away. The interesting part is the r value is always the same. That's what's interesting. Anywhere you pick around here, this is always r. Always has an x piece and it always has a y piece. And then one's smaller, one's bigger in some spots. And when you add them squared, they always equal the r squared value. I think it's kind of cool. Okay. So here's what we want to do. We want to write an equation that satisfies each of these conditions such that like the radius is each of these things. Okay. So let's start with our equation. We're always going to go x squared plus y squared. This one here tells us that the radius is what? 5. So I'm going to plug 5 in for r, right? But I still have to square it. So the actual equation, if you see a number that you can square, you should just automatically go, I'm going to square this. Yeah, right?
Why did you already write 4 squared?
No, it's y, sorry.
I thought you already started solving.
No solving going on here. We're just writing equations. X squared plus y squared. It's 5 squared. But if you see something that you can get a number for, just write it. That's the equation of your circle, whose radius is 5.
So we don't need to find the values of x and y?
Not yet. I don't even think you're going to do that. You might. If I give you a point, then yeah. Okay. This equation has three variables. In order to do anything with it, really, you're going to need 2 of the 3. Otherwise, you're stuck. Right? So if I were to ask you to solve for anything in particular, I'm going to have to give you 2 pieces of information to find the third. That's how it works. Right? You saw that all the way with quadratics. There's 5 things in a quadratic equation. I had to give you 4 of the 5 in order to solve it. Okay? Unless we did substitution elimination. You solve for 1 and plug it back in. That's a different scenario though. Okay? Let's do the next one. I always start with x squared plus y squared is equal to 1 squared. So x squared plus y squared equals 1. Okay? Last one. Now this one will trip somebody up, hopefully. And then we can talk about it. What does this mean? I'm going to write this in a particular way, just because I think everybody needs to see it. Right? I could have distributed the exponent into both top and bottom, but then you still wouldn't understand. Like, I'm using this as an opportunity to teach you multiplying fractions again. Okay, just to review it or to look at it or see it in a different scenario, right? This physically means the squared means that there are 2 of whatever the squared is on. Doesn't matter what it is, it just means that there is 2 of them. In this case, it's 1/3. So I wrote the 1/3 twice. Well, how do I multiply 1/3 and 1/3? It's always top times top and bottom times bottom, right? So I get x squared plus y squared is equal to 1/9. Any craziness? Okay, it's not that bad, actually. But here we go. What would happen? What would happen if I asked you to graph a circle, or at least sketch it? has to be circular of some sort. But what's the radius is your question. That's ultimately what you're after, right? So what r is. Remember, if I were to rewrite the equation, it always has to be x squared plus y squared has to equal r squared. Do I see a squared on that 16? So what am I going to have to do? I'm going to have to, what? Square root it. Okay. So then I'm going to rewrite the equation such that it's 4 squared. What is the radius? Retta. 4. The radius is 4. Right. 4 squared gives me 16 back, which means the radius, when I go to graph this thing, right? When I go to graph this, this is where the iPad's nice because I'm going to get a nice perfect circle, but it's not going to be where I need it to be. Okay. That means this point is what? This one here is 0, 4. This one here is negative 4, 0. And this one here is 0, negative 4. Right? Every point along this circle is going to have a radius of 4 everywhere along there. That's what's cool about the triangle inside of the circle, because it's always 4, but it's a sum of the x piece squared plus the y piece squared, right? That's always going to equal 4 inside of that particular circle with a radius of 4. Okay? If there is anything that I've seen kids mess up on, it's they always say, oh, the radius is 16. Not 16. Because when I rewrite the equation to look like this, it's always r squared, right? Also, don't divide 16 by 2 and get 8. Okay? You got to square root it. It's 4. Okay? That's about the only trick that, or thing that I see go wrong for the most part with this. Okay? Now, here's what we need to do here. I've asked you a question, and I've asked you to solve for something else, or at least the equation. So if you were to write the equation out, equals r squared, I'm going to have to solve for, like, in order to fill this out to make it look like the rest of the equations, I need r, right? So I'm going to have to solve for r. That's the first step. But I've been given an x and y, right? Because it's, you know that the circle, that point lies on the circle. Okay? So I'm just going to plug it in. 3 is x and 7 is y. So it's 3 squared plus 7 squared is equal to r squared. So you're just trying to solve for r, right? 9 plus 49, r squared. So you get 58 equals r squared. So r is equal to root 58. Now, don't type that in your calculator, because what are you going to do in 2 seconds when I rewrite the equation? What is r? R is root 58. Okay, well we have to type in r. R is root 58, but it's r squared. So I still have to square that, right? So it's x squared plus y squared is equal to 58. Because you square a square root, they cancel each other. That's why you don't need to type it into the calculator, because you're just going to get 58 back. Does anybody have any questions with that? It is cool. That's why I say don't type. until you're ready to give me a final answer, don't type things into like square root of 58. Like, don't do that. Okay. Same thing with fractions. Sometimes like fractions can be ugly sometimes, yes, but in other times where like you can manipulate them, or sometimes things just magically cancel and you don't have to ever round anything. You know what I mean? Does anybody have any questions with that one? Okay, let's do this one. So basically what we got going on here is we have one circle. We have a circle. Okay, we know its radius is going to be we know its radius is going to be what? We know r squared has to equal 52, right? Because there it is right there. Right, so r is going to be equal to the root of 52. So here you can actually, I don't mind, for our purposes, r is going to equal 7.6. Okay. Now, you can actually do this one of two ways, I think. They're both related, but you guys saw something yesterday. I showed you guys something yesterday that, okay, let me ask you a question first. What is the radius? Yeah, no, I don't mean, sorry, yeah. Numerically, we know what it is. If I didn't draw a circle here, what would it be? Yeah, forget about a circle for a second. I just think back to yesterday. The radius is just the distance, right? Right? So now I'm going to reintroduce the circle, and here's our question. Our question is this point here inside or outside of the circle? You can do one of two things. The first one I'll show you is we'll use what we did yesterday. This is just me thinking off the top of my head because I'm just trying to tie it together for you. We can find the distance of a line segment, okay, such that we can do, what's the second point here? 0, 0, right? The origin. So we can go 7 minus 0 squared plus 1 minus 0 squared, square rooted. That should look familiar from yesterday, doesn't it? Okay. So the distance of this line segment, or to this point from the origin, will be 49 plus 1, square rooted. D is equal to the root of 50. Okay, there's no units provided, so this is like, you get a nice, you don't have to do centimeters or anything like that. Okay, I want you to look at that number for a sec and interpret what it's asking, right? So, is this point, does it fall inside of the radius of the circle that they've given us, or does it fall to the outside, is the question. Okay, just let everybody, so what does everybody think it is? Inside or outside? I have the outer boundary. I know where the outer boundary of the circle is. It's at 7.615. Right? If the point lied outside of that circle, then this number should be bigger than that one. But it's not. Right? It's smaller, which must mean it lies on the inside. Now, maybe that doesn't resonate with you. Let's do it the other way. All I'm going to do is I'm going to create an equation of a circle, or at least solve for the radius. Actually, it's virtually the same thing, guys. Actually, it's the same thing. What you're going to do is x squared plus y squared is equal to r squared, right? I'm just trying to relate it back to what you guys did yesterday. I'm just trying to solve for what r is, right? You get 49 plus 1 equals r squared. 50 equals r squared. So r equals square root of 50, which we saw 7.07. So I'm going to, just for the purposes of, you guys don't necessarily have room here, but I'm going to redraw this picture here for a sec, okay? I'm just going to draw it a little bit bigger so I can illustrate something. Okay, what I'm going to do here, in blue, I'll do it in red. In red, I'll draw the first circle, the one that they're saying has a radius of 52, okay? That's not gonna work. Oh. Okay. What's the radius of the red circle? We said it had a radius of right? The question is asking us, is the point inside the circle or outside the circle? Or does it like create a circle that's bigger or smaller than the one from the beginning? That's what it's asking us basically, right? So I'm going to go draw the black circle now, right, from here. It's saying it has a radius of 0.07. Well, that's smaller than this number, so it better be on the inside, right? Some of you had some lost looks on your face, so I just want to draw the picture. Is that better? We all see what this question's kind of doing. Just asking us whether or not, like, here's one circle. Here's the radius of another. Is it inside or outside of the initial circle? That's all it's asking. Okay. I found what the radius was of the second circle that they were saying. If the number is bigger than the radius from the first circle, then it better be on the outside. If it's smaller, it better be on the inside, like what we just saw here. And that's it. We have questions? Okay. There you guys go. It's kind of a, I don't know. It rears its head again, somewhere else in a completely different light. But aside from that, like, there's not a lot I can ask you to do with that, aside from, is this inside or outside of that, or what's, just write the equation of the circle, right? Not a lot of fancy stuff.